Good morning to all. This is Divya, working as Assistant Professor in the Department of ECE, R.M.K College of Engineering and Technology, Chennai. In this video, we are going to see the different classifications of systems, out of which the topic what you're going to see now is causal and non-causal systems. Let's get into the video now. First, let us see what is meant by the term called system. Systems process the input signals that it receives and they produce output signals. We have a system, we have an input signal given to that system. The input signal is also called as excitation. We get output signal, otherwise we call it as a response. When a system receives input signal, it produces output signal. The system may be a combination of two or more elements that may process one or more signals and produce one or more output. We have multiple input, multiple output system, single input, multiple output system. We have multiple input, single output system, single input, single output systems. Systems may get more than one signal as input. Systems may produce more than one signal as output. Let's see what is meant by causal and non-causal system now. A system is said to be a causal system if the response of that system at any time instant t depends only on the present input, past output, but it should not depend upon the future input or future output. So here the classification of systems and as causal category, you should not confuse with the term that we defined for the causal type of signals. A signal is said to be a causal signal when it is defined only for positive instant of time. Okay, so they should not worry about causal signal and causal system. A system is said to be a causal system if it is defined, it contains only past input, present input and past output. It should not depend anything on the future input or future output. Then it is said to be a causal system. We have many real-time examples for this causal system. Motion of an automobile is also a causal system. Why? Because it depends upon the past status and present inputs, the driver will be driving the automobile. Here we can see an example. Y of t is equal to 3 into x of t plus x of t minus 1. Here x of t is a current input. X of t minus 1 is a past input. So present output y of t depends upon the present input x of t and the past input x of t minus 1. So while analyzing whether this given system is causal or non-causal, we have to identify the value of the output at least 3 instants of time. Present input 0 and positive time index 1 and negative time index minus 1. At least we have to find values for these things. So first we have seen y of 0. That is at time t equal to 0. The answer is 3 into x of 0 plus x of minus 1. Which means at time instant t equal to 0, the output y of 0 depends upon the current input, present input x of 0 plus past input x of minus 1. Hence, the given system is a causal system, you can say. Let us have some more examples, some more statements to confirm our causal statement. So, t equal to 1 is chosen. Y of 1 is equal to 3 into x of 1 plus x of 0, which means at time index 1, the present output y of 1 depends upon the present input x of 1 and past input. Remember, here we say x of 0 plus x of minus 1. And we call x of minus 1 as past input. Why? Because at time index 0, the past input is x of minus 1. At time index 1, the past input is x of 0. Let us try for x of y of minus 1, that is t is equal to minus 1 also. Then we get 3 into x of minus 1 plus x of minus 1 minus 1, which means what? 3 into x of minus 1 plus x of minus 2. So at time t equal to minus 1, the output y of minus 1 depends upon the present input x of minus 1 plus past input x of minus 2. So for at the time value minus 1, minus 2 is considered as a past input. Hence, the given system is causal system as the present output depends only upon the present and past input. A system is said to be non-causal system when, so actually what we have seen for causal, if the present output depends only on the present input and past output, we call it as causal. If it depends upon future, then we have to call it as a non-causal system. So here non-causal system may depend upon the present input, may depend upon the past input, may depend upon the past output, but it will also depend upon future input. In that case, we call the system as a non-causal system. Example, we can see, we have example y of t is equal to x of t plus 2 plus x of t minus 1. So in order to confirm whether the given system is causal or not, what we have to do? We have to find the output at least 3 different time instant. Let us find for the first instant t equal to 0. Y of 0 is equal to x of 2 plus x of minus 1. So at time index t equal to 0, x of 2 is a future input, x of 0 is the present input. So this is future input. For the next time index, y of 1 is equal to x of 3 plus x of 0. So at time instant 1, x of 3 is the future input. So let us find for t is equal to minus 1, we are getting y of minus 1 is equal to x of 1 plus x of minus 2. At time t equal to minus 1, x of 1 is the future input. So hence we conclude that the output at any time instant depends on the future values also. In addition to the past values, it is depending upon the future values also. Hence the system is called as a non-causal system. So now let us have some more examples to confirm or to practice. Here you can have a discrete time system. Y of n is equal to x of n minus 2 plus x of n plus x of n minus 1. We have to find the value of the output at 3 different time instants. So at time n is equal to 0, what we are getting is y of 0 is equal to x of minus 2 plus x of 0 plus x of minus 1. So at time index 0, we are depending upon the past input, present input. We are not depending upon the future input. So next time index t is equal to 1, what we are getting is y of 1 is equal to x of minus 1 plus x of 1 plus x of 0, which means at present time index t is equal to 1, your output depends upon the past input, past input and past output. You can see here for y of 1, x of 1 is the present input, x of 0 and x of minus 1 are the past inputs. At t equal to minus 1, we are getting y of minus 1 is equal to x of minus 3 plus x of minus 1 plus x of minus 2. So at t equal to minus 1, this x of minus 1 is the present input, x of minus 2, minus 3 are the past inputs. So for any time instant n, your output depends on the present and the past input. Hence the system is a causal system. Let us have one more example. Y of n is equal to x square n plus 2 into x of n plus 3. Same procedure we have to follow. Find the value of output at least 3 different time instant. Y of 0, when you put here 0, x square 0 plus 2 into x of 0 plus 3, which means y of 0 equal to x square of 0 plus 2 into x of 3. At time instant t equal to 0, x of 0 is the present input, but x of 3 is the future input. Next time index, y of 1 is equal to x square of 1 plus 2 into x of 1 plus 3, which means y of 1 is equal to x square of 1 plus 2 into x of 4. So at time instant t equal to 1, the output depends upon the present input x of 1 as well as future input x of 4. Same thing repeats for y of minus 1 also. Since at any time instant we tried, your output depends upon the present as well as future input. Hence the system to be called as a non-causal system. I hope now you understand how to consider a causal system and non-causal system and verify it by applying the values at different time index. Thank you all. We'll meet again in the next video.